Okay, this is video number 2 for our first review packet. Number 5, a farmer wants to buy between 90 and 100 acres of land. He is interested in a rectangular piece of land that is 1,500 yards long and 300 yards wide. The piece of land is being sold as one complete unit for $87,000. If the farmer does not want to spend more than $900 an acre, does the land meet all of his requirements? And just to keep in mind, 1 acre equals 43,560 square feet. So I love to draw little diagrams to always help me. So you have a rectangular piece of land that's 1,500 long and 300 yards wide. So we need to get it down first. If you notice, acres is in square feet. So what are these yards in feet? Okay, multiply them by 3. So this becomes 4,500 feet, and this becomes 900 feet. Multiply by 3 because there's 3 feet in a yard. So area of this land is just 4,500 times 900 feet. So if I multiply those two things together, I get 405,000. So that is 4,050,000 square feet of land. Now, how do we get our square feet of land to acres? Well, 43,560 square feet equal 1 acre. So divide this by 43,560 to get it into acres, which means we have 93 acres. He does not want to spend any more than $900 an acre, so now we multiply this by $900 for his acres. Doing that in a calculator, we get $83,700. And that's how much he wants to spend. They're selling it for $87,000. So does he want to buy it? Does it meet all of his requirements? No. So no, the price, so it's not a yes. No, the price is low enough. Price is not low enough. He wants $83,000. They're selling it for $87,000. So it's not that the price is low. Again, the price is not low enough. No, the amount of land satisfies what he needs, but the price is too high. The land's there, but the price is too high. So your answer for number 5 is D. Okay, number 6. A reporter wants to know the percentage of voters in the state who support building a new highway. What is the reporter's population? This is a statistics problem. So the number of people who live in the state, the people who were interviewed in the state, all voters over 25 years old in the state, all eligible voters in the state. The reporter wants to know the percentage of voters. Okay, so we need to know the voters. We need to know who's voting, who's registered to vote, who support building the new highway. So it's not just the number of people who live in the state. That could include kids. That could include people who can't vote, people who didn't register to vote, people who were interviewed. It has nothing really to do about an interview. Okay? All voters over 25 or all eligible voters. Well, you can be 18 and vote, so I want to know all eligible voters, not just if they're 25 years old. So that is our population. All eligible voters in the state would be her population for this statistics problem. Okay. Number 7. The figure below shows concentric circles, both centered at O. Chord XY is tangent to the smaller circle. Remember, that means it's going to hit the smaller circle just at one exact point. The radius of the larger circle is 15 centimeters. The radius of the smaller circle is 12 centimeters. What is the length of chord XY? So this is actually a lot simpler than it seems. The radius, so from O to Y, because everything is centered at O, so anywhere that I draw a radius to the larger circle, I'm going to just draw it to Y. I could have drawn it to X, is 15 centimeters. The radius of the smaller circle, so that would be going to this point, is 12 centimeters. And if we are tangent, that means we are making a 90-degree angle. So to get this would be B, we would do Pythagorean theorem. It would only get me half of it, and then I would double it. So A squared plus B squared equals C squared. A and B are the legs. Leg is 12, leg is B. So 12 squared plus B squared equals 15 squared. So 12 squared is 144 plus b squared. 15 squared is 225. I would subtract the 144 and I would get b squared equals 225 minus 144, 81, square root, and b is 9. So the length from this tangent point to y is 9, and I need to double that to get the length from this tangent point to x. That would be 9, so your answer is 18 centimeters. Okay, number 8, what is the approximate length of an arc subtended by an angle of 4 pi to the third radians on a circle with a radius of 6 meters? So first, I have a formula. So arc length equals our measure of our arc, which in this case, you don't know, so I'm just going to say measure of the arc, in degrees over 360 times 2 pi r. This is not in degrees, this is in radians. So I can transfer it into degrees by multiplying by 180 over pi. 4 pi to the third times 180 over pi. The pi on top and the pi on bottom will make the pi's disappear. And then I just do 4 times 180, which is 720, divided by 3. I get 240. So 4 pi over 3, 4/3 pi, is also equal to 240 degrees. Now that I know the degrees, I can plug that in and get my arc length. So 240 over 360 times 2 pi times 6, because 6 is my radius. And that's just a plugging it into the calculator and solving. So 12 pi, because 2 times 6, times 240 divided by 360, we get approximately 25.13 meters. So C is your answer there. Okay, number 9. What is the solution to the equation? 2x minus 3 over x minus 1 equals 8x plus 1 over 4x plus 5. This is a proportion, solving an equation, solving a radical equation, which I know you guys were struggling with, but if you just have two fractions set up equal to each other, it's a proportion, so you can do cross multiplication. So 2x minus 3 is going to multiply to the 4x plus 5, so 2x minus 3 times 4x plus 5 equals x minus 1 multiplies to the 8x plus 1. And both of these you could box method to get their quadratics. I was going to do that on a sticky note for space. So box methoding the first. I get 8x squared minus 2x minus 15 equals, box methoding the second, so x minus 1 times 8x plus 1 I get 8x squared minus 7x minus 1. So now let's work on getting everything on one side. If you notice, when I go to subtract my 8x squared, it's going to disappear from both sides. I am going to add 7x also. So I'm going to get 5x minus 15 equals negative 1. Add 15. So now I don't have to do a quadratic, which is nice. 5x equals 14, and then divide by 5. So x equals 14 over 5. Remember, with problems like these, also you could plug all of these in for x and figure out which ends up working. I know it's a lot more work, but if you weren't sure how to go about this problem, you can always take your answers, plug them in for x, and solve and see which two would end up, or which would make the two sides equal. It is a positive 14 over 5, so watch that because there is a negative one. All right, number 10 is a division, radical division, which expression is equivalent to x plus 7 divided by x squared plus 4x minus 21. And that's all getting divided by x plus 5 over x squared plus 8x plus 15 when x is restricted so that the expressions are defined. So first of all, we're going to do keep, change, flip. for division. So I get x plus 7, and I'm also at the same time going to factor these if I can. So what's going to multiply to make negative 21 and add to get a 4? Positive 7, negative 3. Remember, it's keep, change, flip, so we change to multiplication. I'm going to factor this one as well because it's going to go on top. X plus 5 goes on the bottom. What multiplies 15 and adds to 8? X plus 3, x plus 5. So, looking at this now, I can cross cancel or I can cancel top and bottom. So I can cancel the x plus 7 top and bottom. I can cancel the x plus 5 top and bottom. So I end up with x plus 3 over x minus 3, which is a here. Okay, actually pretty simple one. Once you get your factors and then you're able to cross cancel. Number 11, which function has a point of discontinuity at x equals 3 when graphed? Which has a point of discontinuity of x equals 3. So that means at x equals 3 there is a hole or there is an asymptote. It's not defined. So looking at A, it gives us a greater than or equal to 3. So since they can use this expression when x equals 3, and because we have x less than 3 and x greater than or equal to 3, this is not our answer. If I plug in 3 to B, which is my absolute value, 3 minus 3 is just 0, so that's going to work fine. If in C I have x minus 3 over x squared, if I plug 3 in here, then I'm going to get 3 minus 3 over 3 squared. I can have a 0 on top of my fraction, so 0 over 9 is just 0, so it's not C. It is D, and let's check Y. If I plug 3 in for x, 3 plus 2 on top, and 3 squared minus 9. 3 plus 2 on top is 5, but 3 squared is 9, and 9 minus 9 is 0. So because I get a 0 in my denominator on D, that's going to have a point of discontinuity. We can't have 0 in our denominator. Okay, number 12. Joshua is constructing a triangle with a circle inscribed in it. Each vertex of the triangle will have a line passing through it bisecting the angle. No matter where he places the third vertex, the conditions will be true. Each line will always bisect its corresponding vertex angle. The 3 lines will always intersect at the center of the triangle. The circle will always be inscribed inside the triangle. Which type of center exists where the 3 midpoints intersect? So draw yourself a visual. I have a circle, and if it is being inscribed, the circle is inscribed inside a triangle. That means I'm going to have edges of my triangle that are tangent to my circle, and something like that. Ignore those excess lines. Okay? Now, each line will bisect its corresponding angle. So that means I have a line going through here that's going to cut this angle in half. I have a line going through this vertex that's going to cut this angle in half. And I have a line going through this vertex that's going to cut this angle exactly in half. So here's my center that I'm starting to get. The 3 lines will always intersect at the center of the triangle. Their center of the triangle also happens to be the center of the circle. The circle will always be inscribed in the triangle. It's always going to be inside the triangle. As this is happening, I'm also making 90-degree angles because these lines are tangent. I'm making 90-degree angles from the radius to the side of the triangle. Okay. So which type of center exists? This is just a definition. Okay. It's not a centroid. It's not a circumcenter. It's not a midpoint. It is an in-center. If you're not sure about these words, I would look them up and just kind of learn what their definitions mean. But this is an in-center. It's inside the center of the circle and the triangle. And last problem for this video, number 13. The function y equals a, open parentheses, 1.20, close parentheses, t, raised to the t. It models the value of an investment after t years. Based on the function, what is the approximate monthly interest rate? So this right now is a yearly interest rate, and we want to get it down to monthly. So keep in mind that I'm adding 1 to this rate. So 1.2 minus, when we take that 1 off, gets you a 0.2, which is equivalent to 20% interest per year. Since there are how many months in a year? 12. I'm going to take my 0.2 per year and divide it by my 12 months, because there is 12 months in a year. When I divide 0.2 by 12, I get 0.017 or 0.16. Repeating, 0.1666, etc. And remember, we move our decimal over twice, so we get about 1.6% per month. There is no 1.6 exactly in our answer. We're going to get the closest one, which is 1.5. Okay, go ahead, pause the video, take a little stretch break, check your answers, work on the next set of problems, and then watch video number 3.